Hello everyone, welcome back to yet another episode of Classic Arcade Repairs. I am starting a repair on two boards, two boards I should say, two Jump Bug by Rock-Ola boards. Here's the first of them that I grabbed, and it has a tag that says bad graphics. Jump Bug, bad graphics. And the other one is right here, and it had a tag on it. I must have removed it that said does not work. So this one don't work, and this one has bad graphics. I just put together a harness. I had to build a harness for this, and I've got it powered up. And come over and look. This is one of my first videos I'm doing with this cell phone that I have, and I've had this phone for quite a while. I just don't have my camera, so I'm going to try with this cell phone and see how it turns out. This is my first time, believe it or not, viewing Jump Bug. I've never played this. I've never seen it. And I couldn't tell you if the graphics are right or not. So I'm going to have to go do some research on what this is supposed to look like. Are these supposed to be dots? I don't know. Everything looks good. That looks like a Joker. I really don't know. It's interesting, it's got the Galaxian stars in the background. I think I saw some sparklies going on. I'm not exactly sure. Like I said, I'm going to have to... I'll pull this up on MAME and play it through MAME and hear what it sounds like and all that good stuff. Jump Bug, yeah. So I have a little bit of research to do, find out what this is supposed to do. And obviously the first thing I'm going to do is check the EPROMs. These are probably the graphics ROMs right here, and I would imagine this is all program. Could be wrong. There could be some sound ROMs up here. Who knows? I don't know. So Jump Bug, yeah. So let me go ahead and just do a little research, and the first thing I'm going to do is drop all of the data from both sets of ROMs. Make sure that our software is good to go before we go any further. So that'll be number one. So I'll do all of that off camera. Check this game out on both YouTube. I believe John's Arcade has a Jump Bug review and gameplay, so that would be a good source to actually watch him play some of the game and see what it's supposed to look like. It's interesting. This does look like a Galaxian style thing here, whether it's got these 51, these are 5101, 2101 sideways. So it's interesting that this has the Galaxian stars in the background. That's really interesting. Yeah, so. All right, cool. We do some stuff and I'll be back. Okay, this is the other board, and you can hear it. This is the one that didn't have a tag that I thought said didn't work. This one has bad graphics. The other one does not have bad graphics. Yeah, you can see this one don't look right. And another thing about both of these boards is it never like uses your guys. You always have two guys up there. When you die, it does not decrement your lives. Like you have infinite lives. So I don't know what that's all about. Infinite lives, you can play it forever. I don't imagine that's a dip switch setting. That would be stupid, right? I don't know. But this one has bad graphics. The other one looks fine. The other one looks and plays fine, but like this board, it goes forever. You never live out. Just goes on forever. That's very strange. Anyway, so this one has bad graphics. The other one seems to work fine. Other than it never uses any lives, which is weird. I'm gonna have to look into that. Both of them had that problem. That's weird. So we will, yeah, I don't know. I'll check into that. But I just wanted to chime in with this. This one actually works. This is the bad graphics board. All right. Okay, looking at this board here, both of these, first thing I'll say, both of these boards had bad capacitors up here. One of them, I believe it was that one right there, the one without the tag, had a very low volume. You'd turn it all the way up and it would barely come through. And it turned out to be the caps up in the audio section. So I replaced all of the caps on both boards, all of the electrolytics. And that fixed that issue. So this board is actually 100%. This one has a little twinkle problem. And I'll try to show you that. It's got a little twinkle on the bottom of the car, on the bottom of the wheels of the car. Sorry about the loud furnace, but I gotta have the heat. I'll try to show you that twinkle. If I can. I don't know if you can see it, just trust me, there's a twinkle. These are the line buffers right here. And that twinkle just screams line RAM. So what I'm gonna do is I think the best thing to do is remove all of the line RAM, because you can't really, there's not a really good way to test these in circuit. So the best thing to do is just remove them. In process of elimination, find the bad one. So I mean, logic can cause this. A funky logic chip can cause twinkles, but it's much more likely that it is a line RAM. So that's where I'm going to start, is with these. I got to eliminate the line RAM. So these line buffers. So let's do that first. I'm going to get the soldering gun out. I'm going to remove every one of these, and I'm going to socket here. And then I think what I'm going to do is I'm going to place 5 brand new line RAMs in the board, and then go one at a time until the twinkles show up. All right, this thing's been on for a couple of minutes. See the sparklies? It's hard to see. So I got the gun heating up to remove those. And you know what is funny is I went in and I got the dip switch information. And you can set this to infinite lives. Remember when I thought the live counter wasn't decrementing? Is that decrement? Yeah, well, you can set this to unlimited lives. What is the point of that? Why would you set it to unlimited lives? It's just weird to me. Anyway, all right, I just wanted to point that out. I've got it set right now to 3 lives, I think. No, I set it to 5. I set it to 5 lives. So, yeah. All right. There you go. Removed. They are right here. So we'll go ahead and put sockets in the board and put some brand new RAM in there, and then see if our sparklies go away. And then we got to figure out which one of these is bad. Well, I just used my Inquisitor RAM tester, and it told me that this one is bad. So we'll put these 4 back in, replace that one, and see if we get rid of our sparklies. All right. I have new RAM in. This is the new one right here. There's the old one. I've had this board running for about 10 minutes. And the sparklies would show up nearly immediately. After about 1 minute, you'd see those sparkles. And this thing's been on for about 10 minutes, and there are absolutely 0 sparklies now. That was 100% the issue. You will see once this thing cycles through. I'll zoom in. I'll try to anyway. On the little bug, jump bug on the ledge. It's just solid as can be. There's no sparklies at all. So, yeah. That was the issue. Bad RAM. Line RAM. So, the obvious question is, what the hell is a line RAM for? And I'll be honest with you, I invite comments down below. What is the purpose of using line buffering RAM? Because I don't know. I don't get it. And I would love someone to explain it. What it basically, you'll see is, let's say the RAM has a read-write signal that's like this. Okay? And it is a pretty much a set clock, and it might be 6 megahertz. I don't know, something like that. Anyway, let's just say that that's your read-write signal. It's write low, so read write. That's your read-write signal, and then you'll have address blocks up here. Right? Let's say you have a address blocks. And these are generated usually by counters. Okay? And let's say this is address 1, 2, 3, 4, 5, 6, 7, 8, 9, right? And then you'll have data in, and you'll have data out, right? So you will have a write, I'm sorry. Here we have address 1. So we have a write in address 1. And then we have a read from address 1. Now we go to address 2, we have a write in address 2, and we have a read from address 2. So it's almost like you're writing a value into the address, and then you're immediately reading it back out. To me, isn't that like a driver? What is the difference from using this versus using a 367 to just drive a signal, drive a line? Is it the delay, the write delay, the read-write delay? Does that propagate slower than a TTL chip? I don't know the purpose of this. I've never understood the purpose of a buffering RAM. Please, somebody in the comments, please explain to me why this is done, because I would love to know. I'd love to understand that. But anyway, that fixes this board. It had a bad line RAM. Let's go check for sparklies one last time. We'll zoom into our jump bug here on the ledge. And normally you'd see under his tires you'd see sparklies. That's what I was getting. Right under his tires. And here we go. Absolutely no sparkles. Okay, cool. That's going to do it for the jump bugs. That one, the graphics were fine on it. It just had very, very low volume and it needed new caps. I put window coverings on all of the EEPROMs too. And I cleaned all of the EEPROMs. They had nasty adhesive on top of them. I cleaned all of that off and I put new window coverings on both board sets. So that takes care of both jump bugs. This one had the bad RAM and bad caps up here. That's going to do it. Thanks for watching, everybody. Hope you enjoyed. And we'll see you all on the next Classic Arcade Repair. Jump Bug. Alright, we'll see if you can tell the difference in the quality. I've had this board on now. I actually left and just kind of went and did a few things. It's been a few hours. And still no sparklies. Wait for it to come around. Yeah, this thing's been on for a few hours. Went out and hung out with my brother for a little bit. And yeah, no sparkles. Beautiful. But what I wanted to do was wire up. This is a 2125 RAM pinout. What I wanted to do was, and I got it wired up on my analyzer, I want to get on one of these and just kind of take a snapshot of it and look at what it does. These things are weird to me, these line RAMs. And we'll just take a look at how it works. Okay, I actually had to pull the pin out for, schematic for Pac-Man to look up the actual pinout for a 2125, because that is not a 2125 pinout. I knew when I looked in my my files on my analyzer, and I had actually saved a 2125 file, and I loaded it, and it has three chip select lines, 3 pins for chip select, and I had only had 1 chip select pin, so I knew the pinout wasn't right. So I went into the Pac-Man schematic and pulled that, and the 8125 is totally different from this. So I rewired it. It's correct now, and I'm going to go ahead and just kind of do some snapshots. I want to make sure the trigger is clear. And go to the waveform. Let's just start fresh, delete everything, go to overlay. We will look at our chip select, and this thing is active. The chip is selected when it is 0, and I believe it will always be 0. I'm not 100% sure on that. And now we'll go with, how about data in, address, no, delete that. Read write signal, address data out. Okay. Yeah, it's active on 0. So it's active right here. Data in is 0, so the input data is 0. 1E, 0F, 1F. This is the address. 0C, 1C, 0D. How very weird. Yeah, okay. You know what I want to do? Let me mess around with this a little bit. I'm going to make sure that I'm sure I have this thing wired right. But it looks like it's active here. I would have thought this would have been active all the time. Yeah, I don't know. This is strange. Anyway, you have the read write, and it's reading right now from 0, and then it writes, and the data in is 0, so it writes 0. Now it goes to read, Here's read write. Alright. Here's read write. So we're reading from address 18 and it's 0. And then we're writing into address 18, we're writing a 0. So why in the world is data out a 1 here? That must be because when we're writing, this is tri-stated. So that's going to look like a 1. When we're writing, the data out will go tri-stated, so it'll kind of float. So that actually, whenever we are doing a write, this should be high, and it is. But is this ever 1? Are we ever writing a 1? Let's trigger on 1 for the input. Data in, is it ever 1? Yeah. Every once in a while it's a 1, I guess. Yeah. See, it's about impossible to see how to test these like this. You have to just pull the thing out and test it in your RAM tester. Yeah, because we're data in is a 1 and we're not writing that 1. It would have to be a wider pulse. There. Here we go, but it's not active. Remember, it's active only at 0. And there's a 0, but there's no 1. It's like it's only doing 1, and that's why you see this down here. When would it write a 1? Would it ever write a 1? Yeah, I don't know. This is just a little bit weird. So it's like all of these addresses, 9E, 8F, 9F, 9B, 8B, or that's 88, 98. This is just 89, 99. 8A, 9A, 8B, 9B. Yeah, this is strange. Surely I got this thing wired correctly. I don't know. Anyway, it's just how all of these addresses, this thing will write into 9E. We are writing into 9E a 0. And while we're writing, this goes high. And then we read, and if it's always writing 0, it'll always be 0 down here, right? So the only time that this will not be active and it will just disconnect, and that's what these 1s are. These 1s are actually just this thing disconnecting because it's writing. So it's creating a just a 0, a bunch of zeros with floating parts. I don't know. That's weird. This is weird to me. I don't get it. I don't get why they do this. I'm being honest. And how come it continues to do the same thing when it's not selected? Something tells me I don't have this thing wired correctly. I don't have a schematic for this. I don't have a schematic for this board. I could not find any information on jump bug. Yeah, I don't know. This is weird. I do have the Pac-Man schematic, which uses 2125 RAM. And they're right here. MB 8125. That is 2125. Yeah. AA. I don't know what that is. 0, 1, 4. Yeah, I don't know. It just looks a little strange to me. Anyway. Yeah. Chip select. Select on 0. Seems like you'd see when this thing is not, when it is not selected, seems like you'd see something different down here. Or maybe it'd be high all the time when it's not selected. It just looks funny that it's continuing to do the same thing when the chip is not selected. It just doesn't seem right to me. I don't know if I don't know. I'm doubting that this thing is hooked up right. I'm going to go ahead, get off camera, and just look this over. This is how I set this up. This is an 8125. That's the same thing as the 2125s on Pac-Man. Yeah, I don't know. Just very strange. Alright. Yep, I'll be back. Alright, in a weird, strange turn of events, this is not a 2125 RAM. These are 2115s. No, they are not. Those are clearly 2125. This board has 2115. Alright, I'm going to have to do a little research, because I know in the Inquisitor, the 2115 is a different test than the 2125. I don't know what's going on here. Yeah, I don't exactly know what's happening here. I'll be back. Yeah, just kind of looking at this. I was looking at that board. Pins 12 and 13 are tied to ground. That's address bits 6 and 5. 6 and 5, address bits 6 and 5 are tied to ground. So that right here would mean that our addresses would always be 0 something, 8 something, or 9 something. And that's what I see on here. Our addresses are 0 or 1. Did I say 1 something? It's going to be 0, 1, 8, or 9. So here's 0 something and 1 something. There's 9 something and 8 something. And now it's enabled and it's doing it. It looks like this thing just writes zeros, and it writes and then it reads, and since there's 0 in every location, it's reading 0 until it writes again, and it writes 0. And then it reads right here, it reads 0, and then it writes again, and that's why this goes high, because it's tri-stated. It's disconnected. Yeah. Very weird. I don't know. Anyway, yeah, like I said, what is the purpose of this? Why is this utilized in this way? Because I don't know. Comment below and let's have a discussion about what is going on here. What is the deal with line buffering? Because I don't quite understand it. So anyway, that's going to do it. This one works great. No more nonsense. No more sparklies. Yeah, and I guess 2115 is the same pinout and functionality as a 2125. Because this one clearly has 2115s on it. This one has 2125s. So, yeah, I don't know. Weird stuff. Anyway, that's going to do it. And we will see you all on the next Classic Arcade Repair. Bye for now. Actually, I cannot end this without playing a game of Jump Bug. So, let's turn out some lights. Okay. Get my Atari joystick hooked up. And let's do it. I'm terrible at this. Oh, I put it on infinite lives. You know what I'm going to do? Let me take it off of that. And restart. Now I got it on 5 lives. I put it back to that so that I could just watch the jump bug while I was looking for sparklies. Now, 5 lives. I got it on easy too, I think. Well. Damn it. Damn. One more. One more. Man, I'm terrible. Alright, now I'm going to play the other board. I'm going to go ahead and turn this off. I'm going to set the dip switches first on the other board to the same thing. Okay. Turn this off, put the other board in. So this one is good to go. And now we're putting the other board in. Okay, that one's turned on. And play a game. Dang it! This game is not easy. Pretty cool. I actually had a pretty good game. that is it. That's both the boards. Jump bug. I can see this being a fun game. I can see this being a popular game because it's really pretty fun. But yeah, that was both boards. There's the other one I played the first time. This is the second one, so good to go. Both of them. That is going to do it. We'll see you all on the next Classic Arcade Repair. And you know, one of them said bad graphics. One of the pins was out of the socket on the it didn't actually have bad graphics. One of them had a flaky. This one had a flaky. Maybe that's what I don't even think that's what they meant by bad graphics. Maybe. But one of these boards, I forget which one it was. I think it was this one maybe. One of the legs was out of the circuit. So it looked goofy. And maybe I got that on camera. I don't remember. But it was just as simply as putting this chip back in the socket. But this one had the flaky. This is the one with the RAM that I replaced. So, yeah, 2 jump bug boards. Good to go. That'll do it. We'll see you all on the next Classic Arcade Repair. Bye for now.